Let's go on to the next problem. A 2016 study concluded that about 3.6% of United States college students used marijuana in any form on a daily basis. A 2019 study of 1,250 U.S. college students found that 54 used marijuana daily, with a 10% level of significance. Tests claim that the daily marijuana use among college students has increased since the 2016 study. We still have to go through steps A through K, but before we go through those steps, let's deconstruct the problem. X, again, is the number of things or people that match the criterion under consideration. So we're talking about college students who use marijuana daily. In this problem, X is equal to 54. Now I'm going to start to go through these quickly because the first problem that we did is a pretty long explanation, and I'm hoping that you catch on to some of these things as we go along. And total number of people or things, that says right here, out of 1250 people. P hat, again, still equals the same thing, X over N. And for this sample, P hat is equal to 54 over 1250, or 0.0432. Q hat, 1 minus P hat, which is 0.9568. P, or the population proportion of people or things that is commonly accepted as truth. This is usually what the previous study or survey showed as the proportion of people or things that match the criteria under consideration, and we always test against that number. So basically, it's the proportion that's just given to you in the problem, and in this case, it's 3.6%. Stated as a decimal is 0.036. Q is 1 minus P. The level of confidence is not given to us directly in the problem, but it's an easy calculation, and that's why it's part of this deconstruction process. I give you a 10% level of significance for this problem, which means that we have a 90% level of confidence. It's just the complement of the level of significance. So what that means is we can do the quick math and let our level of confidence equal 0.90. Alpha was simply given to us in the problem as 10%, so alpha is equal to 0.10. Now that we've deconstructed the problem and did all the simple arithmetic stuff, let's go through the steps of the hypothesis test. Determine whether this is a test of mean or proportion. It's a test of proportion because we're given stuff as a percent. Determine the correct sampling distribution. For all things that are tests of proportion, we simply use the standard normal distribution. Determine if this test is a left tail, two tail, or right tail test. Again, there's no simple formulaic way of doing this. We just have to look for key words. And a key word we have here is increased. So we're testing that daily marijuana use among college students has increased since the 2016 study, which means that it is a right tail test. Set up the null and alternate hypotheses. So remember, that's the H with the little 0 next to it. And we'll have P equals some number. That's the null hypothesis. And the alternate hypothesis is H with a little 1 as a subscript next to it. P is going to be greater than some number. And that number is 0.036 because that's what we accept as truth. And we also put it as P right here. The critical value and the rejection regions, well, that's done by the level of confidence or level of significance. And we just type it in. Because this is a test of proportion, we use the norm.s.in function. And because it's a one-tailed test, we put in alpha. Since it's a right-tailed test, we take the absolute value of our result of that and make it positive. That's what all this explains right here. So here's what we have so far. We have all of the numbers from the deconstruction process. And now we have a test about a population proportion. We know that. So since we know that, the sampling distribution is the standard normal distribution. The key words increased indicates that this is a right-tailed test. So my null hypothesis is P equals the number we consider to be truth, which is 3.6%, or as a decimal, 0.036. And my alternate hypothesis is P is greater than 0.036. My rejection region is now on the right side of this graph. And my critical value, well, here's the boundary right here, kind of in a red color. And let's see. So critical value is equal to the absolute value of the norm.s.in of 0.10, which I did on a spreadsheet. And again, I will do all of these problems all over again on a spreadsheet. And we have, it's approximately equal to 1.282. So that's the boundary where my critical value is, which is where the rejection region starts or ends, depending upon how you look at it. Now, we have to calculate the test statistic. Here's the formula, same as it was before. And for this problem, here are the numbers we put in, and we get a test statistic of approximately 1.3665. On the graph, or the diagram, it looks like this. My rejection region is right here. Critical value begins here. My test statistic barely falls in, but does fall into my rejection region, which means in this case, I reject the null hypothesis. Since the test statistic falls within the rejection region, we reject the null hypothesis. So we reject now what we had known to be truth, which is that 3.6% number. Since this is a one-tailed test, and because we reject the null hypothesis, in layperson's terminology, we simply restate the words in the problem. Thus, we have, with a 90% level of confidence, it seems that daily marijuana use among college students has increased since the 2016 study. This is the final slide from the problem. Let's take a good look at these numbers, and I'm going to put these numbers on a spreadsheet. So let's go to spreadsheet mode. X in that problem was equal to 54. N was equal to 1,250, which means that P hat ended up being 0.0432. Q hat is equal to 0.9568. P for that problem was 0.036. And Q is calculated for us as 1 minus P. Level of confidence for that, even though they gave us a level of significance, I always just like, for consistency's sake, to type in my level of confidence as 0.90, which means my alpha is 0.10 or 0.1. Alpha over 2 is 0.05, which gives me a critical value of, in this case, because it's a right-tailed test, positive 1.282. Test statistic automatically calculated for us because we did this in the last problem. I'm not going to retype it again. Ends up being 1.366, etc. So since this is a right-tailed test and my test statistic is to the right of my critical value, my test statistic is in my rejection region. Let's go back. My test statistic is clearly in the rejection region. Just by a little bit, but If it's in the rejection region, then we know it's statistically significant enough to say we can reject the null hypothesis or reject what we had known as truth, and it's statistically significant enough to say that it is greater than what we used to know as truth. So, in layperson's terms, again, we would say with a 90% level of confidence, it seems that the daily marijuana use among college students has increased since the 2016 study.